The next two videos in this playlist is all about conversion factors and the calculation parts of this chapter. So a conversion factor is an equivalent, and we use conversion factors all the time in everyday life. Okay, we look at a dollar and we're like, oh, well, we have 4 quarters or 10 dimes or 20 nickels or 100 pennies. They're all the same thing. Well, the same thing holds true with our scientific measurements and calculations. We use these conversion factors as a ratio of equivalence so that we can change our units so that we can calculate things correctly. We know 1 foot is equal to 12 inches, or that 12 inches is equal to 1 foot. Well, since these things are equal to one another, if we write them as a dimension, which means as a numerator and a denominator, since these two things are the same, this in essence is 1 over 1. So mathematically, we can use this dimension here, or this dimension here, to convert, 3 feet into however many inches we have, or 48 inches into how many feet. So we're going to use a specific method called dimensional analysis in order to convert things. And the reason why we teach this technique at the beginning of this year is because we're going to use it all the time here in chemistry and next year when you guys have physics as well. Okay, it's going to allow for you to use units um, as conversion factors to get between different units. And I know I used the word unit a couple times there, but it really does help you out in the long run, especially if you might be a little bit confused about, the difference between a mole or a molecule. And there's lots of terms that are very similar, and until you get a good, firm working understanding of all that, you're going to need to rely heavily on dimensional analysis. So to start this off, I always like to start with converting. If you just turned 17 years old right now, this split second, how many seconds old are you? So we're doing 17 years, and we want to know how many seconds that's going to be. Well, do you know the conversion factor between 17 years and seconds? No, I don't either. All right, so that means we have to figure out how we can get there, how many multiple steps of conversions we're going to need to know. All right, so when we do these problems, it's good that you identify what's given. So that's going to be the number that you have, 17 years. And the unknown would be how many or how much or what, the whatever, who, what, where, why, when, how, the question word of the whole thing, of the whole sentence. So we're looking for seconds. So what do we know? Well, I know in 1 year I have 365.25 days. Why do I have 0.25? Because we have an unequal revolution around our sun. So every 4 years we have to have a leap day. So to account for that, it's 365.25. Well, once you're in days, you can then change your days into hours. There's 24 hours in a day. Okay, and 1 hour is equal to, yeah, 60 minutes. And then 1 minute is equal to 60 seconds. So what we're going to do is we're going to change my 17 years to days. Then we're going to take our days and we're going to change them to hours. Then we're going to take our hours and we're going to change them to minutes. And then we're going to take our minutes and we're going to change them into seconds so that we get our unknown at the end. Okay, so when we do this, and we have these conversions, these 365, this 24, this 60, and this 60, we need to know if we are multiplying 17 by them, or are we dividing by them, and this is how you would position this. Okay, so when we start off with our problems, okay, when you go to solve, you start with the given. That's where you begin everything. So 17 years. I have 1, 2, 3, 4 conversions. So I'm going to make 1, 2, 3, 4 conversion factors here, 4 dimensions. And I'm going to choose this one, which is years. To start off with means I'm going to use this conversion factor first. And if I want to get rid of years, I put years in the denominator and 365.25 days in the numerator. Okay? So years and years will cancel out and I will use that piece of information. When you go to solve something and simplify it in math class, if you had 2x over 2, the 2's would cancel out. Okay, your 2 here would end up canceling out with the denominator 2 there. They're on opposite sides, leaving you with x. So if you have years times days over years, guess what cancels out? Your years and your years, leaving your days. Okay, so that's the whole principle behind this dimensional analysis, which is sometimes called the factor label method. All right, so now that we have days, we want to get rid of days. So 1 day is 24 hours. If days are here, I'm going to put 1 day on the bottom so it cancels out, and 24 hours in the numerator. That way, days and days cancel out. I used that piece of information, and then we have hours left. But I don't want hours, I want seconds, so I have to keep going. But I think you can figure it out. Okay, hours are here. I put 1 hour on the bottom, 60 minutes on top here. All right, hours and hours are going to cancel out. And then I want to get rid of minutes. So my last section is to get rid of 1 minute on the bottom. Oops, M-I-N. Let's erase that and make it prettier. Oops. Minute. And 60 seconds up top. And that way, minutes and minutes cancel out, and I'm left with seconds. So everything should cancel out except for the unit I am looking for. Okay, so how do we solve this in our calculator? Well, if it's in the numerator, you multiply it. If it's in the denominator, you divide. So in one fell swoop, 17 times 365.25 times 24 times 60 times 60, and then divide by 1, divide by 1, divide by 1. You can choose to do it or not. It's the identity property. You don't have to do that. But in your calculator, you should get 536,479, 200 seconds. So 536,479,200 seconds if you turn 17 years old right now. All right, so again, make sure that your units cancel out and you go each step making sure that each one of your units is going to cancel out on the other side. And then you have your seconds that are left. Make sure that you solve each one like so. Put it into your calculator, and then you are going to see, voila, you end up having your 536,479, 2,000 seconds. So now let's go the other way. Let's try to figure out how many years old you are if you live for 1,000,000,000 seconds. How much is 1,000,000,000? 1 comma 0, 0, 0 is 1,000. This is 1,000,000. 1,000,000,000 is 3 commas. This is 1 times 10 to the 9th seconds. Okay, very, very long time. Or is it? Okay, so how many years is that going to be? That's going to be when we take the same exact conversion factors, but we're going to apply them differently. Okay, we still know that 1 year is 365.25 days. We know that 1 day is 24 hours. 1 hour is going to be your 60 minutes. And we know that 1 minute is 60 seconds. So we can apply all of these into the exact same scenario and have all of our units convert perfectly. So here we have everything labeled out for us, okay, our 3 commas here for a billion seconds. Just so to save room, I'm going to put it as 1E9, like what you're going to put in the calculator. So 1 times 10 to the 9th seconds. And then I have 4 conversion factors, so I'm going to set up 4 dimensions. And I'm going to start with seconds because that's what they said. Oops, this is a typo. Typo here. This is seconds and this is years. Oops, forget about that. But what we have here is our seconds. So I'm going to start down here. 60 seconds is 1 minute. If 60 seconds are here, I'm going to go down, put 60 seconds on the bottom, 1 minute on top, and I'm going to cancel out seconds and seconds. Next, I'm going to cancel out minutes. Well, there's 60 minutes in an hour. So I'm going to use 60 minutes on the bottom, 1 hour up top. And I'm going to cancel out minutes and minutes. Next, I'm going to cancel out hours. There's 24 hours in a day. So I'm going to put 24 hours on the bottom and 1 day up top. And that's going to give me hours and hours to cancel out. And then I'm going to have 365.25 days in my denominator, and 1 year, the unit that I want, is going to be up on the top. So days and days will cancel out, leaving years, which is exactly what I want here. So in my calculator, what do? I type in 1E9 times 1 times 1 times 1 times 1, if you want to do all that. It's the exact same thing. It's the identity property. And then I divide by each of these denominators. Divide by 60, divide by 60, divide by 24, divide by 365.25 days. And what do I get? I end up getting 31.68 years. So when you hit your 30s, you're 31 and 2/3 almost, you are going to be a billion seconds old. Okay, so 1E9, we're going to cancel out our seconds here, seconds and seconds. Then we're going to cancel out our minutes. Then we're going to cancel out our hours. And lastly, cancel out our days, leaving the unit that we want, years. So in your calculator, you can either put 1 billion seconds or 1E9, and then your times ones, divide by 60, divide by 24, and you get your 31.68 years old. And that is dimensional analysis.